Hello and welcome to our unit on surface area. This first unit is going to be on surface area of prisms and cylinders, and you're going to hopefully realize that these two concepts are very much related to each other. So let's start with surface area. Surface area is the total area, or surface area, total area on the surface or outermost part of a three-dimensional object. So if we have, for instance, let's do this in pink so you don't have to copy it down. If we, for instance, have a cube, it'd be the outermost part. Let's do this in, here's our cube. It's the outermost part, so we have 6 sides to the cube. And we would calculate the actual area of each side. So 6 sides times the area of one of those squares, you'd get your total surface area. Now, if it's a rectangular prism, for instance, if we have some kind of longer piece, then obviously it wouldn't be times 6. We would solve each side individually, and actually there's a nice formula for it. And lastly, if you have, for instance, some kind of weird prism, like a triangular prism, then you would have 3 different lateral sides, because there are 3 sides to the triangle, and each of these triangles are the bases. Okay, so that's going to be an important feature to this, and I'll get into that in a little bit. But here we would have a cube, here we would have a rectangular prism, and then we have a triangular prism. Now, which brings the definition of a prism. A prism is a three-dimensional object, whose bases are congruent and let's leave it as simple as that for now. So if you notice, when we're talking about bases, I'm going to highlight the bases here. The top and the bottom are considered our bases. And in this triangular prism, you have to be very, very specific, because since it's a triangular prism, the triangles are the bases. Also notice that when I drew these, I made the top, the actual triangles, the bases of them, in the name, the actual top and bottom. If I were to actually draw this triangular prism this way, let's say it was lying flat. If you've ever seen a Toblerone, then you know that it has this generic shape. The dotted line is the part that you can't see. The triangles would actually still be the bases in this particular diagram, because it's a triangular prism. So another way to draw it is like this drawing that I just drew, and the bases don't change. Okay, it has to be whatever is that name. They have to be congruent to each other, because if you look closely, if you consider this bottom part the base, there is no top part that is actually congruent to it, right? There is no top base to that, because it points up like a tent. So we treat this as if the triangles are the bases. Okay, so here, let's draw a rectangular prism. All right, notice I'm drawing it kind of like a rhombus or like a parallelogram. We're going to draw some vertical lines. So these would be parallel. Then we would draw some more pieces to this. All right. And then we're going to connect this back piece with dotted lines. And technically, we should also have these pieces here, because we technically can't see them. These would also be dotted lines as well, because we cannot see those parts of the rectangular prism. They are in the back left corner or the bottom part. So in this particular case, we consider the top and the bottom the bases. So I'm going to highlight these purple. And this is what we consider the base, this whole area inside. Okay? Just like I did with the triangles over there. Those are the bases. So let's make sure we note that. This is the base, as well as this piece. Okay? Which means the sides of this is what we call a base edge. All right. And lastly, we also have, not lastly, I should say, we also have lateral edges. Now, lateral, it's kind of like in football. When you do a lateral in football, you're either tossing the ball to someone, a teammate that is sideways or that is behind you. In this particular case, we are talking about something that is sideways, and we're going to look at the sides of the prism. So these are your lateral sides, which means all of this is your far left side that you can't really see. This is the far back side. Then here would be the far right side. And then we would obviously have the front side, entire front side of this. Okay? Those are your lateral edges and lateral sides. So here, we would call that a lateral edge. And you could even go as far as to call this an altitude, or even the height. I'm going to call this an altitude for the most part because it's going to be confusing with what the height of like a triangular prism it would be, or the trapezoidal prism. You'll see what I mean in our examples. So I'm going to call this almost exclusively the altitude, and you'll see what I mean in a second. Okay. The nice part about rectangular prisms is that you could actually write this, you could actually draw this any way. You could like turn it on its side and it would still be rectangular prism with bases changed. The unfortunate part is when you actually have triangular or pentagonal prisms, you have to use the pentagon as the base. Okay, so in this particular case, let's actually break this apart. If this was an actual box, we could cut this up. For instance, if I cut this up so that we, could lay it flat on the ground, we would have the tall pieces, the lateral edges, cut up into multiple sides. 4 rectangles that make up the 4 sides, the left, the front, the back, and the right. Then you would have the bases on the top and the bottom. So you would have a base on the top or the bottom. You would have a base on the top. And together, this all together, this would, you could fold this all up and it would make this rectangular prism. Okay? If I actually put dimensions on this, we could actually lay them out onto this, what we call this is a net. I'm going to do this in pink. You do not have to copy this part down. I did this in color just so you could kind of visualize this with the diagram to the left. But if I put, for instance, values here, if I put 8 inches here, 6 inches here, and 10 inches here, then we could actually overlay it onto this net. Okay, we would have an 8 on the inches, 6 inches on the side, and then 10 for the height, which means we'd have 8 inches here, we'd have 6 inches here, which means since we have 8, then the next side over would be 6 inches, which means, so because these are adjacent to each other, just like how these are, the next one over would be 8 inches, next one over would be 6 inches. And notice this 10 inches carries over for all of them. Okay, 10 inches, 10 inches. This should all be in pink, but you get the idea, right? 10 inches all around for all the altitudes. Now, if we're talking about surface area, we need to calculate the surface area of all of the sides together. So what that means is, all of the surface areas, all of the areas together, the 6 areas together. So we would calculate this triangle's area, which we easily could. We could calculate this one, this one, this one, because it's all base times height, right? And if you really think about it, if you look, let's call this rectangle A. Rectangle A is the same as this one here because they have the same dimensions. This one here, B, let's actually put this in pink. Let's call this A. We could call this one B because it's 6 times 10. This would also be B, 6 times 10. We could say this is 80 inches squared, 80 inches squared. This would be 60 inches squared, which means this is 60 inches squared. And then this would be 8 times 6, which is 48, and 48. And what we could do is we could just add all of this up together. Now, this is very tedious to do because there are 3 different rectangles that we actually need to solve for. I'm going to show you an even easier way to do this particular problem, okay? But we are literally calculating all of the areas for this. So, if you notice, 80 plus 60 plus 80 plus 60, or you could do 80 times 2, which is 160, plus 120 will give you 280 inches squared. We would then combine this with the bases, because you have 2 different bases here. 48 times 2, which gives you 96 inches squared, and then you could add these together. This would be 376 inches squared. Okay? Now, I did say there's an easier way to do this. And there's a nice formula for this as long as you understand this key concept. Okay? The formula states that the lateral area, which is all of the blue area, all 4 sides, is equal to the perimeter of the base. So let's go P base, capital P for perimeter, perimeter of the base times altitude. We understand that this would go a long way. And then we could call this surface area, SA, surface area. Let's actually write it out, surface area. And actually let's write out the lateral area. It'll probably be better, so you know what I'm talking about. Lateral area. Let's move this over. And let's actually write altitude in, so we know exactly what I'm talking about. Lateral area is equal to perimeter of the base times altitude. The total surface area, or total area, is going to be equal to lateral area. Now I'm going to shorthand it, plus 2 times the base. Okay? Now, perimeter of the base is the purple, right? And that means we have 8 plus 6 plus 8 plus 6. Or we just have 28. So the perimeter of the base is actually equal to 28 times the altitude of 10. If you notice, 28 times 10 is 280. Didn't we just calculate that here by solving for all 4 of these rectangles together? Absolutely. So that's why this is actually a more convenient equation. Okay? And if you notice, 2 times the base is the same thing we just did here. Calculate the area of one base, 8 times 6. 8 times 6 is 48. And then times 2 for the 2 bases, which gives us 96. And then just like it does here, we do 280 plus the 96. And we get our total surface area of 376 inches squared. Okay? So, the most important concept to this is knowing what your base is. Okay? Knowing this is very important. Because like I drew here, we have to know, in this particular case, the triangles are the bases. Even if it's drawn this particular way, we need to know that the triangles are the base. Or if it's, for instance, a pentagonal prism. Okay? we have a pentagon drawn here. This is a bad drawing, but you hopefully can see this. The pentagon is the actual bases, okay? Base of a pentagon. All right. So you have to realize, okay, the base is the pentagon, which means this is our altitude. The altitude goes from base to base, okay? So this is your equation for it. Surface area, these are the two equations you will need. All right. Stay tuned because we're going to continue this with cylinders. We'll talk about that in just a second. I'll see you in the next one. Bye.